Okay, graphs that deceive, a non-zero vertical axis. A common deceptive graph involves using a vertical scale that starts at some value greater than 0 to exaggerate differences between groups. Always examine the graph carefully to see whether a vertical axis begins at some point other than 0 so that differences are exaggerated. Over here, if you take a look, we have the OxyContin and then placebo, and then we have the percentage experiencing nausea. Now, if you notice down here, they start at 10%. So it shows that this is much larger than this placebo. Now, if we take a look at the one to the right, it's starting at 0, and you can see that these two actually are much closer than what it shows here. And this is a deceiving tactic, to start at 10% instead of 0%. Now, pictographs. These are drawings of objects called pictographs, are often misleading. Data that are one-dimensional in nature, such as budget amounts, are often depicted with two-dimensional objects, such as dollar bills, or three-dimensional objects, such as stacks of coins, homes, or barrels. By using pictographs, artists can create false impressions that grossly distort differences by using these simple principles of basic geometry. When you double each side of a square, its area doesn't merely double, it increases by a factor of 4. When you double each side of a cube, its volume doesn't merely double, it increases by a factor of 8. Now, here's a pictograph of U.S. National Security Agency collected phone records. It says here, year 1, 151 million, and year 2, 534 million. You can see that these particular phones are now exaggerated here to not necessarily show the proper way of what these amounts look like. So if you doubled, right? If you doubled 151, what does that give you, right? So let's go ahead and try that here. So if we take 151, let me go ahead and minimize this here. So we're looking in terms of 151. So if we take 151 and then multiply it by 2, that's 302 million, right? Now, if we take 151 and multiply it by 4, that gives us about 604 million. So you can see here that, again, a double each side of the square, its area doesn't necessarily mean double. So in this case here, what are they saying? What's going on from year 1 to year 2? Does this picture represent a good picture for us to look at or not? Those are the things that you need to think about when you're looking at those particular graphs. Now, the concluding thoughts. In addition to the graphs we have discussed in this section, there are many other useful graphs, some of which have not yet been created. The world needs more people who can create original graphs that enlighten us about the nature of data. In the visual display of quantitative information, Edward Tuff offers these principles. For small data sets of 20 values or fewer, use a table instead of a graph. A graph of data should make us focus on the true nature of the data, not on the other elements, such as eye-catching but distracting design features. Do not distort the data. Construct a graph to reveal the true nature of the data, and then almost all the ink in the graph should be used for the data, not for the other design elements.